Hey there, pre-algebra students. I'm glad to talk to you today. You've turned in your Chapter 7 test now. That's fantastic. And so it'll be a little bit before I finish grading them. I still have a couple people that I need to figure out why theirs didn't get turned in, but I am getting them to you shortly. Today we want to start our discussion of what we call relations and functions. You may have already seen them at some point, but we're going to treat it as if you've never seen them. So I want you to think of a relation as being like a relationship. Okay, there's a relation between two numbers or two things, and they're connected in some way. Now here in this chart, I have students numbered 1, 2, 3, 4, 5, 6, 7. Not very creative as far as names go, but I wanted to make it into numbers so we can kind of get an idea of what a relation looks like and that it has meaning. It's important to understand that these things have meaning. A lot of times in the math, when we start studying them, we get so caught up in the numbers and finding out what x equals or whatever that is, but we lose sight of the fact that these things are all meant to have some attachment to real life as far as the numbers representing something. So these students 1 to 7, if you want to, you can choose what number you want to be you. And then over here I've got birth months. So student 1 was born in March. Student 2 was born in April. Student 3 was also born in March. We have a January birthday here. We have a July birthday here, a December here, and an August here. So if your birth month is not on there, I'm really, really sorry, but this was just kind of a random list I put together. So we had a relation to deal with. If you'll notice, this particular relation is given in list form. Sometimes we'll have a relation given in list form where you have x and y as your variable that attach to the lists, but for right now we're using a student and birth month form for that. So there's a relationship between those numbers. All right, you should know from your past that these can be written in what we call ordered pairs. The order makes a difference. So if you're going to always put the student first, okay, notice what I've got here. I'm making a brace. And when you're doing these and you're writing them out, you really need to use the correct format. So you're going to make a brace. If you have trouble making it really like that, you can always do bump, point, bump. But do your best effort to make one, even if it's in bump and an end to our look at an ordered pair. And you also have to think that, gee, I wonder if we're going to be graphing it a little later. Yep, we are. So my ordered pair is where my x value is my student number and my y value is the birth month. Okay, x value is the student number, y value is the birth month. X value is the student number, y value is the birth month. And you go through, and if you're writing them as a list of ordered pairs, you have to go through and write them down one by one by one. Now this one happens to have 1, 2, 3, 4, 5, 6 with no gaps in there. But it is quite possible that you just have a list of ordered pairs that has some gaps. It's possible that you have positives and negatives. It's possible that you have decimals in there. All right, so you have all these things happening. Okay, so I've now produced this list of pairs, and that's the first thing that you need to be able to do with a relation that has two lists of numbers, maybe an x and a y, but maybe with actual meaning behind it. So when you look at an ordered pair that's in this list, if you know what the labels represent, you can say, just look at this list and say this was student 6 and they were born in December. This is student 4 and they were born in January. So the order makes a difference in the ordered pair. We have an X value and we have a Y value. All right, now what we can also think about is something called a domain and a range. I'm kind of guessing you might have heard this before, but just in case you didn't, the domain is the list of all the X values in your relation. This is called a relation because they have a relationship. So here's my relation. The domain is the list of the X values in the relation. You can go ahead and write that down. The relation. So for this particular relation, my domain, once again, we're using this bracket notation, is you go through and you make a list of all the X's that are in your list. In this case, 1, 2, 3, 4, 5, 6, and 7. And then our range, okay, our range is the list of the Y values in the relation. Oops, sorry about that. I'll erase it. By relation. So we look at this and you're thinking about, okay, well, what are the Y values? Well, let's go through. We can do them one at a time. 3 is one of the Y values. 4 is one of the Y values. Now this 3 got used a second time as a Y value. You do not list it again. You list it only once, even if it's in your list twice as a Y value. I have 1 as a Y value. I have 7. I have 12. And I have 8. So in this case, it's really just a list of all of the months when people have birthdays. Okay, so they're birthday months. We have people who have birthdays in March, April, January, July, December, and August. But we would not list it twice, even though there are 2 people that have birthdays in March, we only list it once. So same thing for the domain. If there was a repeat in the domain, you would have to list that number just one time if it's in the list, even if it's in the list twice. And we'll talk about that in a minute. So you've got, I'm taking us through this whole example and then we'll go back and do a couple of more. But this particular relation is special. This particular relation is what we call a function. And a function is where each one of the members of the domain has just one value of the range that makes sense for that. So for example, the birthday function is actually a pretty common function to discuss because each person has only one birthday. It would be impossible for student 5 to have a birth month, a physical birth month, in both July and August. It would be impossible for student 4 to have a birth month that was in January and December, or January and August at the same time for their physical birth month. Any function means that each X value has only one value, one y value. Now it is okay for two people to be born in the same birth month. So a function is allowed to have repeats in the y values, but it's not okay for it to have repeats in the x values. I'll say that again. It's okay to have repeats in the y values, but it's not okay to have repeats in the x values if it's what we call a function. You can have a relation that has repeats in the x values, but if there are any repeats in the x values, then it can't be a function. And repeats in the y values are fine all the time. Okay, so I have run you through the basics of all of these things except for the idea of graphing. And then we'll do some more examples because you need to see some things that are functions, that are not. We need to make sure that you understand about finding domain and range. So I want to pull this information that I just had, and I want to take this relation, this list of ordered pairs, and I want to show it to you in graphing form. So I'm going to bring this up. Some things work better in one screen, some in the other. I'm going to put this, paste it right down here. There we go. So here's our relation. And what I want to do is I want to graph it as graph these ordered pairs. Notice that this is all positive, so when I'm making my graph I can stay mostly in the positive area, but I'm going to do this. I'll make my y-axis. I'm going to make my x-axis down here. I think I've given myself enough room. If you do not have graph paper at home, what you might want to do, if you have a printer, you could probably find some graph paper to print. If you have to do worst comes to worst, use some lined notebook paper and just do your best. However, it is best if you can get ready to practice on graph paper. So I have my x-axis and I have my y-axis, as you are aware. I'm going to put some graphed points on here. Okay, ordered pair 1, 3, and you should be able to graph these. You know how to do that. Ordered pair 2, 4. Ordered pair 3, 3. 4, 1. 5, 7. 1, 2, 3, 4, 5, 6, 7. 6, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what are we up to? 7, 8. 7, 1, 2, 3, 4, 5, 6, 7, 8. All right, so what you notice about this is that each one of these vertical lines has only one point on it. And in order to tell if something's a function or not, you can always check the vertical lines. And if each one of the up and down lines has only one point on it, it absolutely has to be a function. Okay? And we call that the vertical line test, that tells you if you have a function or if you do not have a function. This is a function because each one of the vertical lines has just one point on it. Every x value has just one y value. I don't care about this horizontal line. It's allowed to have multiple points on it. But the vertical lines, the up and down lines, can only have one point on it in order to be a function. So what I would like to do is I'd like to bring us through a few examples, not too terribly many, but let's just make up some examples here so that you have something to look at. And we will go from there. I want to make sure I've got a good pencil here. Good. That's kind of like when I click on those, it's kind of like I'm sharpening my pencil. So let's do something with decimals. Now we're not actually going to graph this one. Oops, and I didn't make an ordered pair, did I? I just put a number. I want to make an ordered pair. I'm going to say 1.2, comma 7. And I'm going to do 3, 2.9. And I'm going to do 1.2 and negative 6. And I'm going to do 4, 0. So there are some typical questions that you're going to be asked. I did put the homework assignment into GradeLink as far as what problem numbers. It's also on the assignment sheet that you'll find on the web page. The assignment sheet on the web page has the things that you need for this week. Honestly, if I didn't have all these videos to produce, I would have had a complete assignment sheet, but I want to make it reasonable in length for each assignment, so I'm going to be producing it as we go, but at least what you need for the next few days is on it. So just keep looking. I will be revising it and adding assignments to it as we go through the next couple weeks. So for tonight, you're going to be working on just things like this. One of the questions might ask you to find the domain. So if you are supposed to find the domain of this function, that means you need to make a list of which values? You need to make a list of the x values. So we're going to go through. Here's an x value, 1.2. 3, 1.2, oh, that's a repeat. I don't write that one again, and 4. So there are our domain values, 1.2, 3, 1.2 that I don't write again, and a 4. Our range is going to be the y values. So you could be asked the question, state the range. As a matter of fact, the first couple questions say state the domain and state the range. So here is 7, 2.9, negative 6, and 0. And I know because your students, much like many other students that I've had through the years, a lot of people want to cut corners and not put in the braces on the ends. And a lot of people want to not put the commas in between. But please put the commas in between. Please put the braces on the end, even if it's not perfect, like this one's a little blobby. I'm not concerned so much with that, but I'm concerned with making sure that you're getting used to the right notation. Okay, it's a little bit harder because I'm not looking over your shoulder to make sure you're doing it, but I need you to do that to make sure that you're doing the domain and the range and you're making these lists. This is a very beginning of a concept that's going to follow you through all the way through your algebras, and then especially those that will go into maths that are beyond algebras. The domain and the range become super important. So this is where we need to start. The domain is the list of the x's, and the range is the list of the range is the list of the y's. So now we need to ask the question, it's a function or not a function? Now remember what I said a minute ago. It's a function as long as each x value has only one y value that it goes with. But look at here. Here's 1.2, and it goes with the 7. But over here, it's 1.2 goes with negative 6. Now, depending on where this relationship comes from, that could make perfect sense. But it's not in that same category as the birthdays, where the x value can have only one y value. In this case, 1.2 matches up with 7. 1.2 also matches up with negative 6. So this is not a function. In order to be a function, the x value can only go with one y value. Okay, it doesn't matter how many times a y value is repeated, but if an x value gets used more than one time and it goes to different y values, then it is not a function. So that's important for you to know. Let's do another one. Okay, so let's start off now in this case with this particular set of numbers, set of ordered pairs. All right, let's do 2 and 8. Let's do 7 and 3. Let's do 5 and -2. And let's do 6 and 8. All right, so we're going to ask the question, what's the domain, what's the range, and is it a function? So our domain here, our list of x values, you should try to do this by yourself, like pause it and then try and do it and see if you were right. But our x values, when we look at the domain values, we've got 2, we've got 7, we've got 5, we've got 6. 2, 7, 5, 6. All right. Our range. Let's find our range values. Our range values will be 8, 3, -2, and 8 gets used again. So 8, 3, -2. Since 8 got used again, we do not write it twice. So our question, is it a function or not? So what we do, we look at all of the x values and make sure that each x value goes only to one y value. 2 just goes with 8, 7 just goes with 3, 5 just goes with -2, and 6 just goes with 8. So yes, it is a function. It's okay that 2 went with 8 and 6 went with 8. That's fine. But each one of these x values had only one y value, so that makes it a function for you. Okay, I hope that makes it clear. I want to look at something with graphs, because another thing that you could be asked would be to have a graph, and then you could be asked to, first of all, write the list of ordered pairs, and then after writing the list of ordered pairs, you might be asked to determine if it's a function or not a function. So what I want to do is I want to put some spots on here. So I'm going to put an ordered pair here. I'm going to put an ordered pair here. I'll put one here. And I'm going to put one here. All right, so I'm going to see if this will let me copy paste it, because it's not letting me write very well over here, but let me see. I don't think it's going to, but I can do a snip. I'm going to do a snip. Okay. So if you ever wondered how these things get made, here you are live and in person. I can do a screen snip here. And I can copy it. And then I'm going to put it right on the other thing on the paint so that I can edit it. All right, there we go. So I have my little, my graph here that I've made. It has an x-axis and it has a y-axis. X and y. And it could, the directions could say write the relation as a set of ordered pairs. Now that word set is what's telling you that you need to use the braces. This. Ordered pairs means you go through and you, if I'm working from left to right, that helps me to make sure I don't miss anything. So here I have the ordered pair -2, -1. Here I have the ordered pair -2, 0. Here I have the ordered pair 1, 2. And here I have the ordered pair 3, -2. So I followed the first direction. You could be asked for the domain. The domain x values being -2, 1, and 3 without the extra loop. And then you could be asked to find the range. The range being all of the y values, which in this case would be -1, 0, 2, and -2. You could be asked if it's a function or not. And I want to show you with the least way of having to think about too much to do this. Like I said before, if you look along these lines, all right, and you're looking at the dots, if there's any place where there's more than one dot on one of these vertical lines, then it is not a function. So right here you've got this one and you've got this one. That automatically tells you that one of your x values is sharing a y value. So this one is no, not a function. Okay, so writing the relation as an ordered pairs, I think that that's pretty easy and we've done enough with that. And I think we have done enough with explaining how to tell when you have a list of ordered pairs, what to do with that. But as far as figuring function or not, but I want to just give a few quick graphs for you to tell function or not. By that rule, it's called the vertical line test. So let's take a look here. Let's make a few graphs. So this, we can use the vertical line test. I'm going to type that in for you to write down. Vertical line test to check to see if it's a function. Okay, 2 or more points on the same vertical line means it is not a function. Okay, so looking at this one, when you are trying to do this, just like I said, this one is not a function, and it is not a function because it fails the vertical line test. This vertical line has more than one. Let's just look at a couple more quickly, and then you'll get to work on your assignment. All right, we have x and we have y. Let me do this time. That's great. I can put dots on pretty easily. So I'll put one here, I'll put one here, I'll put one here, I'll put one here, over here, over here, over here. So our question is function or not a function? And I'll give you a second to think about that. And the answer is not a function. And the reason it is not a function is because it fails the vertical line test. It actually fails the vertical line test two places. It fails it here because you've got 3 points right on the same vertical line, and it fails it here because you've got 3 points or 2 points on the same vertical line. So this fails in two different ways. It fails the vertical line test. So we've got to say that that one's not a function. Let's look at another graph. I can actually put a few graphs on here just so you can check. I want you to think about them as they're going up, and then I'll tell you the answers afterwards. So please excuse my slightly crooked line here. Okay, I want you to be thinking about them, and I'll go over the answers just real quick at the end. So here we have some dots, and putting them in here. There we go. And you need to think function or not a function on these. And if you were to ask to write the list of ordered pairs and find domain and range, I have no doubt that you could do that as well. But right now we're just checking to see if you understand about that vertical line test. Each one of these blobs is meant to be an individual dot, by the way. And let's do another one. And so here we have this one, this one, this one, this one. There's my grumpy dog making a little noise in the back. He's a good dog. He's just a little bit goofy. All right, then we have, actually back on this one, I'm going to put one more point right here. And here I'm going to put this one, this one, this one, this one, this. Okay, so let's go through and think it through, function or not a function. This one, let's check all of our vertical lines. This one is a function. If we look at all of the places where you have vertical lines, you have all the vertical lines have just 1 point on it, so it is a function. Don't care about this. Doesn't matter horizontal lines, but the vertical lines, that one's a function. This one is not a function. Where does it fail the vertical line test? It fails it here. There's 2 points on the one line. This one is not a function. Not a function because right here, this is where it fails. These two dots are on the same vertical line. This one has a whole bunch on the same horizontal line, but that's horizontal line. We don't really care about that one. So this one is a function. All right, so I've explained to you how to find function or not a function based on vertical lines. I've explained to you what a domain is and what a range is. There is a word problem where you're asked to think a few things through, number 43. I do want you to give it a try and see what you can come up with on that one. Think about there's 2 columns. The first column think about as being x values and the second column being y values, and try and figure it out in that way, and we will be able to hopefully answer any questions that you have if you have any questions on the exit form for this. Okay, everybody, I miss you. I really, really, really want to be back in school and being able to help you in person, but until that time, I am still praying for you, and I can't wait to see you. Have a great rest of your day.